Good morning, class. I've been getting a few questions about how can we test our collections for a particular type of thing, and I thought maybe we should spend a little bit more time kind of digging into types and working with types versus working with instances of classes. Make sure that we really understand what that is. So for example, if we look at the chili cheese fries class, the chili cheese fries itself is the type of the objects that are created from this class definition. They also can be cast to the type of side because they inherit from that abstract base class. So we can think about the types of an instance of chili cheese fries as being the chili cheese fries, the side, and object, which is the base class of all objects in C#. So those are what those are. Now working with types is a little interesting. We can refer to them directly by the name. We can also use the type of operator to pull out the type of an object. We can also invoke getType on any object. That's one of the methods that's defined in the object, and that will tell us what the type of that object is. Now when it comes to testing, we do have a couple assertions that help us deal with that. So let's go ahead and think about our test, what we need to test for with our sides. So we should be able to get the sides out of the menu, and we want to make sure that it has a chili cheese fries, a baked bean, a corn dodgers, and a pan de campo, and ideally it should only have those 4 entries in it. Unless you have chosen to actually represent multiple sizes of the sides in yours, in which case you should have 12 entries, one for each size of each one of those entries. And either one of those approaches is fine. It just is a different amount of tests that you're going to have to write in either case. So we might be tempted to do something like public void menu sides should contain expected stuff, let's just say. Now, we'll set that as a fact, and then you could do something like, we need our X unit in here. So when we're working with collections, we do have an assertion specifically for collections, which is assert collection, and that's going to take an IEnumerable of type T, and it's going to iterate through that, and you're going to pass in another collection of what we call element inspectors. And notice this is an action. That's basically meaning that we're going to pass in some kind of delegate that's going to actually do the assertions we care about. So we could say menu.sides here. When we run this test, it's going to look at the collection menu.sides, and then for each item it pulls out of that. So for these 4 items, it's going to first off make sure that there are exactly 4 items, and then it's going to look at these in order, and we can add our own assertions inside the body here. So for example, well, actually all we really care about here is this actually a chili cheese fries? So we can do assert, and we can use that type. There are couple different ones. We have isType, which checks is the fully quantified type of that type. And so we could say chili cheese fries are the base type. And actually that is a templated method. So we actually pass that in as the template value, and then we just invoke it. Yeah, and we have to pass in the actual object we're looking at. And since we put this inside of the body, we have to have that semicolon. So basically what we're doing is the first item is CCF. So we're going to take that item and pass it into this assert isType method, which is going to run the assertion checking that its absolute type, or the thing it is most or furthest down that inheritance chain, is a chili cheese fries. And then we can do assert isType for the next one, which is baked beans. assert.isType of corn dodgers, and assert pan de campo. And that would actually test this collection, make sure that all this stuff we expect is in there, and we have exactly the 4 entries. Let's go ahead and run that particular test. I'm just going to run that one specific test. And you can see that this is actually failing. And if you wonder why, look, the assert is type failure. The expected type was Cowboy Cafe data chili cheese fries. The actual type was Cowboy Cafe data baked beans. And really what's going on here is this assert.collection, assert.collection, these come in the exact order they come out of the list. So we have to look at those in that exact order. And actually my baked beans, I actually put these in alphabetical order, so the baked beans needs to come before the chili cheese fries. And if we were to run that again, you can see now our test passes. So this is one possible way of doing this. But as we saw, it actually is a brittle way, because if we ever reorder how we're providing this list, this entire test will now fail. So it's a perfectly acceptable way of doing it, but you need to be aware that that does introduce that limitation that these are going to be expected to be in that order. Now, we could, for example, take our menu.sides and maybe put it in a new list. And pre-sort the list so that we knew it was going to be in this order. So we could do, so for example, sides.sort, and we have to sort it. We could use the default compare, but we're not sure what that's actually going to be. We could declare our own compare, and actually that's probably what we'll do. So we'll actually say item A, item B coming in, and we want to determine if A, and I would probably sort by the name, or what we actually get when we convert it to a string. And we can invoke compare to with b.toString. So that will use string comparison on the actual name. That puts them in alphabetical order, so we can then do this list in alphabetical order. There. Now that's slightly less brittle, because now if we were to go to our menu and change that order so that it's not in alphabetical order anymore and rerun that test, it should still pass. And you can see it does pass. Now that's not the only way that we can do this. One of the other ways we could do the test is, rather than dealing with it in one collection like this, we could actually break these out into individual tests. So we could, for example, look at the sides should contain just chili cheese fries. So how could we do that? And in this case, we would want to look and see, and you might be tempted to do assert.contains. And we would take in the object that we expect it to contain and evaluate it from there. Now, the problem is, what we actually want to know is if it contains something of a specific type. And contains doesn't actually do that. What it does is it takes the item that you're passing in, which might be the menu, or the first thing is a collection, so that would be menu.sides. And then we want to know, does it contain something that is the type of, say, chili cheese fries. Now, this is not going to work because we're comparing an object to a type, and we can't do that. So is there any other way we can get around this? Well, one thing we could do is take our objects, convert them into types, and then we could actually do that comparison. So we would want to take maybe a type, a list of types, and populate this list with all the types that come out of that menu.sides. So we could do a for each. And I order item in menu.sides. And then pull out that type and add it to our list of types. So we take our item, iterate through our list of all our sides, we take the item out, we invoke type of on it and add it to this array of types. So we're making a collection of the types. And actually, we'll do this type of, it actually does a comparison test. We want get type. And that will actually extract the type, the actual symbol, which is a type, and add it to this collection that we've just created, which is a list of types. And then we can look at our types list. Yeah, doesn't look like it likes that because we cannot convert from system.type to, oh, I got this backwards. We're looking for the type of chili cheese fries, which is just a type. The second argument is the collection we're looking through. Do that correctly. Yeah, expected value. There we go. So we extract the type chili cheese fries from the symbol chili cheese fries, or the name of the class. So we're getting the actual type. We're comparing that to the type out of the list. And this is how we can do these individually, or one of the ways we can do them individually. So let's go ahead and take a look at our test there. So we've added this new test, should contain chili cheese fries. We'll go and it passes. So we are seeing that indeed we are getting the correct type out of this. So if we go this way, we would have to do all the types. Another way we could do that is we could turn this into a theory. And side should contain item, and go ahead and pull in this type. So instead of doing type of chili cheese fries, we could just pass in this type variable. And of course, as a theory, we need to provide inline data. And then we could do our chili cheese fries. And I need a second parenthesis there. And we can do all four of the types that we need to deal with. So baked beans, pan di campo, And our other side is corn dodgers. So what we're doing is we're going to run this test 4 times. For each type that we've specified, they're going to come into here. We have to convert, again, our menu sides into a list of types. In other languages, we'd actually call this a map function, and there is a map function similar that we can use that's based on link. I'm not going to introduce that just yet because we're going to talk about link next week, but that will come. But basically what we're doing is we're converting the list from actual objects into the types of those objects. That list we're passing into assert.contains. We're checking that that type is in that list. So if we do that one, that will also get us all of our types. We can go ahead and run that test. Notice now in our Test Explorer, now we have 4 tests associated with this, which are all of the 4 types. We can go ahead and run that. And they all pass. Now, the other difference we need to think about between doing these type tests individually and doing them with this assert.collection. Assert.collection also checks that there are exactly 4 entries here. Here we're not doing that, so we have to add an extra test to cover checking that we have just the 4 items. And that's actually pretty easy to check. Do assert.equals, and we will say should equal 4, and menu.sides.count or length. Okay, that's actually a method that comes from system link. If we were returning something other than an IEnumerable, if we're actually returning a list, the list has that length property. If we were returning a let's be an invocation, there we go. So there we are checking to see, does the current count of the sides equal 4? And like I said, because menu.sides is returning that IEnumerable, it doesn't by default have a length or count property. If we're returning an array, we could look at the length property. If we're returning a list, we could look at the count property. Or we can use, like I said, coming out of the link namespace, adds an extension method to IEnumerable called count, which is, depending on what kind of underlying object it is, will potentially invoke the length or the count if it's a list or an array, or it's going to basically count by iterating through all the values. So it's not necessarily the most efficient way of doing it, but we're not really worried about that in terms of testing. And now we should have that one additional test. So really there are 2 basic approaches that you would use potentially to test your collections. You can either use the collection test like we did with this menu should contain expected stuff, or you're going to test for each item individually and then test the overall count, which both kind of give you an assurance that you have exactly the things you need and nothing else being returned from that method. So that gives you a couple different strategies to think about. You can pick whichever one you're most comfortable with.